Hello students. Hello and welcome to this video. In this video we will solve question number 131 to 140 of the determinant. The link to download the PDF will be in description, as well as at the end I will show you my website from where you can download the updated PDFs and maintain an updated copy. I will also show you my question answer website where you can come and ask questions or give answers. So without further ado, let's get started. Question 131 says that we have to show that this determinant 1 plus a square minus b square 2ab minus 2b 2ab 1 minus a square plus b square 2a 2b minus 2a 1 minus a square minus b square is equal to 1 plus a square plus b square whole to the power 3. So let's see this how we do this. So we multiply column 3 with b and subtract from column 1, that is c1 minus b3, and c2 is equal to c2 plus a3. So we get this determinant 1 plus a square plus b square 0 minus 2b 0 1 plus a square plus b square 2a b times 1 plus a square plus b square minus a 1 plus a square plus b square 1 minus a square minus b square. And once we have that, we expand it and we immediately get the right answer. Question 132 says that if ABC are sides of a triangle, show that a square s minus a whole square s minus b whole square s minus b whole square b square s minus b whole square. This should be s minus a whole square. This shouldn't be s minus b. S minus c whole square s minus c whole square c square is equal to half p square a square, where p denotes the perimeter of the triangle, a its area, and s is equal to perimeter over 2. So we know that perimeter is equal to a plus b plus c perimeter, right? Yeah. And this a is not there in the denominator. This is wrong. And area is equal to square root of s times s minus a times s minus b times s minus c. And the problem is same as 91. We just need to substitute for the values of a and p. So I'll show you question 91 quickly so that you can understand. So this was 91. It is the same problem, okay, which we had. So we solve like 91. If you have not watched the previous videos, you need to go and watch the previous videos. Okay. Question 133 says that show that x minus a whole square ab ac ba x minus b whole square bc ca cb x minus c whole square is equal to x square times x minus 2a times x minus 2b times x minus 2c multiplied by x plus a square upon x minus 2a plus b square upon x minus 2b plus c square upon x minus 2c. So we take ABC common from rows and multiplying the column given is the same determinant as in the problem 88 and can be solved in same fashion. So again we have to refer to a previous problem. So we look at problem 88 again. So some problems are variations of other problems. So this is problem 88, okay. And if you look at problem 88 and problem 133, that is this one, you will see the similarity. So if you take ABC from rows, okay, multiply columns first, multiply columns by ABC, and then you take ABC common from rows, okay. So you don't, yeah, that's all right. So whether you multiply first or later doesn't matter. You will end up with the same determinant. So question 134 says that if x, y, z are unequal and x, the determinant x cube, x plus a whole cube, x minus a whole cube, y cube, y plus a whole cube, y minus a whole cube, z cube, z plus a whole cube, z minus, this should be a, this shouldn't be z whole cube, okay. So there are typing mistakes. Is equal to 0. Prove that a square times a plus x plus y plus z is equal to 3xyz. Note that x, y, z are unequal. So what we do here is we do column 2 is equal to column 2 minus column 3. We will be left with 6x square a plus 2a cube. We take 2 common, we are left with 3x square a plus a cube, 3y square a plus a cube, and so on. Once we have that, what we do is column 3 is equal to column 3 minus column 1 plus column 2. We will be left with 3x a square, 3y a square, 3z a square. Once we have this, what we do is we take a square column from this and a from this. Okay, so we get 2a cube. And then what we do is, R2 is equal to R2 minus R1, R3 is equal to R. This should be R3 minus R1. Okay? This shouldn't be 2, this should be 3. Once we do that, we have this determinant, and we can take y minus x and z minus x common. And once we do that, we follow it by expansion, and we will have our desired condition. So some work is left for you. You do it, and if there is any problem, let me know. I'll be able to help you. Best you come to the question answer website and ask if there is a problem in this one. Now, where will be question 135? Show that 1 minus x a square, a square minus x, a cube, a square, a cube, a to the power 4 minus x is equal to x square times 1 plus a square plus a cube minus x cube. So what we do in 135 is we do c3 is equal to c3 minus ac2. So we do AC2, so we get a 0, we get x, and we get minus x. So we take x common. So this will be 1, and this will be minus 1. So then we do R2 is equal to R2 plus R3, so that we get a 0 here, and we have minus 1 here. After that, it is a matter of expansion and simplification, nothing complicated. Question 136 says that if y is equal to sine px and yn is equal to nth differential of x with respect to y, find the value of y, y1, y2, y3, y4, y5, y6, y7, y8. Okay. So we look at the given function y is equal to sine px, and we see that y1 is equal to p cos px, y2 is equal to minus p square sine px, y3 is equal to minus p cube cos px, y4 is equal to p to the power 4 sine px, and so on. So essentially, if you look at the last row, y6, y7, y8, all will be minus p6, minus p7, and p8. Okay, sine and cos we ignore. So from these three, we can take out minus p to the power 6 out. Okay, once we take minus p to the power 6 out, first row is identical to last row, and so the delta will become 0. Question 137 says that evaluate cos square theta, cos theta sin theta minus sin theta, cos theta sin theta, sin square theta, cos theta sin theta minus cos theta 0. So here what we do is we do column 1 is equal to column 1 minus sin theta column 3, and column 2 is equal to column 2 plus cos theta 3 multiplied by 3, that is. And once we do that, we have got plenty of zeros, and we expand and we get cos square theta plus sin square theta is equal to 1. Question 138 says that evaluate cos alpha sin alpha cos beta sin alpha sin beta minus sin alpha cos alpha sin beta 0 minus sin beta cos beta. Okay. So in this one, what we do is column 3 is equal to column 3 minus tan beta column 2. So tan beta multiplied by this, so minus column 2. So these two will become 0. Okay. And the third value becomes 1 upon cos beta. So we expand for this 1 upon cos beta, we get the value as 1. Question 139 says that solve the equation a square plus x ab ac, ab b square plus x bc, ac bc c square plus x is equal to 0. So you know how we solve this. We multiply the columns with the ABC, and in the outside we divide ABC. Once we have that, we take ABC column common from rows. So our determinant becomes a square plus x b square c square, a square b square plus x c square, a square b square c square plus x. Once we have this form, we do r1 is equal to r1 minus r3, and r2 is equal to r2 minus r3. And once we have that, we have 2 minus x here. We subtract how we do here. We have here this. Okay, so we do column 3 is equal to column 3 plus column 1. So we get 2 zeros. And once we have 2 zeros, we expand along this x. We get x is equal to 0 and minus a square plus b square plus c square. Question 140 says that solve the equation for x, xcr, n minus 1 cr, n minus 1 cr minus 1, x plus 1 cr, n cr, n cr minus 1, x plus 2 cr, n plus 1 cr, n plus 1 cr minus 1 is equal to for all n and r greater than 1. So by observation, if x is equal to n minus 1, then first two columns are same. Similarly, if x is equal to n, then first column is equal to sum of other two columns. So x is equal to n and n minus 1 are two possible solutions. If that is the observation, you can see that if x is n minus 1, then it becomes identical to this. And if x is equal to n, then it is sum of these two columns. Okay, so n and n minus 1 will be two solutions. Now we take x factorial over r factorial times x minus r factorial common from the first column, and similarly for second and third, then we get a quadratic equation which will have two roots, and we have found both of them. So with this we come to the end of question 140. So let me show you the website. The website is astrotalker.org, and let me zoom a bit. You can download algebra, trigonometry and coordinate geometry from second, third and fourth links. PDFs won't have dates, so you take this date and add it to the downloaded PDF. I cannot add the date to the PDF because that will make existing links invalid. Now after 15 or 30 days, you should visit again and see if the PDF has been updated, and if the PDF is updated, you can download again and update your copy. This HTML format is going to go out. We will not have that. We will have only PDF copies here. So coordinate geometry is coming towards end, and very soon we should be able to finalize coordinate geometry, and then we will move on to calculus. Now about the question answer website, you can hit indica.astrotalker.org, or you can click its link. So here you come and make a login. You have tags for maths, algebra, calculus, coordinate geometry, geometry, probability, trigonometry. And if these do not satisfy your question, then you can use mathematics to tag your problem. So please make a login and ask your questions over here. Okay. With this, I will end this video here, and I hope that you are able to learn something and you found this video useful. So we'll meet again tomorrow with 10 more questions on determinants, and till then, stay curious, keep learning, and most importantly, enjoy.